Hello everyone, this is Akansha from GDSA, and today is our third session of this DSA Bootcamp. And for today's, our topic is searching. Now, searching is really an interesting and fun topic once you understand it. So, without further ado, let's get started. And for that, I want Shreya to first explain the basic theory, and then we will move towards the problem section. So, Shreya.
Hello everyone. So let's get started with today's topic, that is searching. So what is searching? Searching is basically a process of finding a certain element inside a list of different values. It determines whether an element is present inside the data or not. So there are basically two types of searchings, that is linear search and binary search. Now let's look into each one of these one by one. First one is linear search. So it is a type of sequential search. In this method, we search for the given element by visiting all of the elements one by one until that element is found or the array is completed. Uh, let's take an example. Suppose we have a class students, and one of the students have the candy. So if you're searching for that student, the student with the candy fashion, what will you do for that? You will go to each of the students one by one, and you will ask, do you have the candy or not, until you found the student that is having the candy. So let's see with an example of an array. So we're given this array, search for the element 2 inside it. So search this 2 one by one by traversing each of the element until we find the element that is, we can see it is present at index 4. So first of all, we'll start from 0th index, index 0, and the element present here is 7. So is 7 equal to 2? It is not. So we will just simply move on to the index 1, that is the next index. Again, we will check this element present at index 1. So this is not equal to 2. So again, we will move on to index, that is index 2. Again, you can see 3 is not equal to 2. So we will move on to the next index, 3. So 3 at index 3, we have 8 over here, which is again not equal to 2. That is the element we are looking for. So we will move on to the next index, that is 4. At index 4, you can see 2 is present over here. So you can see the element we are searching for is present at index 4. Now let's see the code for linear search. So we are passing an array and the element to be searched for inside this linear search function. So what we will do, we will start a loop from 0 to the last index, that is array size. And we are going to compare each of the element and we are going to check if it is the element that we are looking for. So if it is equal to the element that we are looking for, we will simply return the index that we have found our element at this index. Otherwise, we will just return -1. What this means? This means that there is no such element inside the array. Now, the next method is binary search. So what is binary search? Binary search is a type of interval search. Now, you can only apply this on sorted array. You cannot apply this on unsorted array. So what this method does, this method reduces the search space to half each time a wrong element is found. So if you apply this binary search to the room of 50 students that we have talked earlier, and you have to find the student that is having the candy. So what you will do if you are applying the binary search, you will divide the whole class into two groups of 25 students. And now you will ask, which group have the candy. Let's say group number 2 have the candy. So now you're not going to search it in the first group. You'll just leave it and move on to the second group. Further, you will divide the second group into two parts, and you will ask each group which group have the candy. And you are going to leave the one which doesn't have the candy. So you're going to repeat this process until you find the candy or the group can further. So this is what it means by reducing the search space by half. Each time you are getting a wrong input, you are dividing the group into two groups again. So how you implement a binary search? You take three integers, low, mid, and high. Low is initialized at the index 0 and high is initialized at the highest index. And we will calculate the value of mid after each iteration. This mid value basically contains the middle value between high and low. Let's see the code for binary search. So you can see here we have taken an array and this is the size of the array, and we are passing the element that we have to search for. We have taken three integers, low, mid, and high, and we have initialized low as 0, and high we have kept at highest index, that is size minus 1. So we're going to start a loop until low remains smaller than or equal to high. And we're going to calculate the value of mid after each iteration, that is low plus high divided by 2. So we can have three cases over here. Case 1 is the value present at the index mid is equal to the element that we're looking for. So this means that we're going to return the index that is mid. This is where we have. Case number 2 could be the element that is present at index mid is smaller than the element that we're looking for. So what we will do, we will update the value of low as mid plus 1. Case number 3 can be this value at mid index greater than the element that will. We will just update the value of high as mid minus 1. Or after this loop is passed and none of these value, and if we have not find our value, we will just return minus 1. So this will be clear with an example. So let's see an example. So here we have taken an array. You can see we have this sorted array. So if you have unsorted array and you want to apply binary search on it, you have to first sort it, right? So in this array, we have to search for element 3. So what were the first step? We take low as 0 and mid as the highest index, that is 8 in this case. After that, we have to calculate the value of mid. So mid is equals to low plus high divided by 2. Low in this case is 0, high is 8, and this becomes 4. So mid becomes 4 over here, and the value is 5. So you can see 5 is greater than the element that we're looking for. So this is case 3. So what we will do in this case, we will just update the value of high as mid minus 1. Mid is what? 4. 4 minus 1 is 3. So here you can see high becomes 3. So what we did over here, if the array is greater than the element that we're looking for, we have already said that this array is sorted. So अगर हमें यहाँ पे 5 मिल रहा है और ये sorted array है, so हमें पता होगा कि 2 इससे पहले आएगा, बाद में नहीं आ सकता. So we left this part, the second half of the array, and we are only going to search the first half of the array. So the search space is reduced to half. So here we have high is equals to 3. Now we are again going to calculate mid value, that is 0 plus 3 divided by 2 becomes 1. So we have mid value equals to 1. So this time we have the element 2 over here. So this we can see is smaller than 3. So this is case 2. Array mid is smaller than the element that we're looking for. So what we do? We update the value of low as mid plus 1. So mid over here is 1. So 1 plus 1 is 2. So low becomes 2. Again we have to calculate the value of mid. Mid is low plus high. So 2 plus 3 divided by 2, which is 2. So we have low is equals to 2 and mid as well. Mid also equals to 2. You can see over here. Now this is the ideal case. You can see at mid the value is 3. So we have found our element. This is case number 1. So we can say that element 3 is present at mid index, that is 2. So we can just return this index 2, that we have found our element at index. So now for you all, suppose you have a large amount of data. What do you think we should apply on it? A linear search or a binary search? Binary search. Binary. Binary, yes. Right. And what about, yes, it is faster. And what about if we have very small data? Are you still going to apply binary search on it? No. Right, Vishesh? We are not going to apply binary search on it. If we have a smaller size of data, and we have to search for an element inside it, we use linear search for that. So these are basic differences between linear search and binary search. One is linear search is a sequential approach. So sequential approach, we have seen that it just traverses the array one by one until it finds the element, or the element is not present in the array and we have reached the end of the array. Whereas in binary search, it is a divide and conquer approach. So we divide the problem into two halves and we check which one is right, and we just solve it further dividing into two halves. So this is the divide and conquer approach. Next is linear search works on both sorted as well as unsorted arrays. Whereas we have seen binary search works only on sorted arrays. We have to sort the array before applying binary search. Next, this is the point I was talking about. Small, if you have small size data, apply the linear search over there, and if the data is of large size, then apply binary search. Next is the complexity. So linear search have the linear time complexity, order of n complexity, and binary search have order of log n time complexity. So this is all about the theory part. Now I want you all to open your IDEs because this is the time to solve the questions. And for that we have Agam over here. Agam, I would like you to
Hello
take.
everyone. Thank you, Shreya. Let me share the screen first.
Your ID while he's sharing the screen so you can solve side by side.
Am I audible?
screen is visible and your voice is also clear.
Okay, thank you. So, hello everyone. Let's move towards the questions. Uh, so, the first question is find first and last position of element in the sorted array. Given an array of integer nums sorted in non-decreasing, find the starting and ending position of the given target value. If the target is not found in the array, return -1 -1. So, can anyone tell me how can we solve this? Any approach? Basically, we have to find the first and last occurrence of the given target value. Can anyone tell me? So, let's move toward the question. So, first approach that comes to my mind is I can search for the target and find the occurrences of the. For doing this, I can traverse the array linearly. First, we can apply the linear search. Mm, for we can compare each element of the with the target element. If the element is equal to target, then we can update our variables. So let us take first two variables. First, which represents the first position of the target in the array, and last, which represent the last position of the target in the array. Initially, they are initialized with the value -1. So we can start traversing on the array one by one. So first, when I equals to 0, is 5 equals to 8? No. Is 7 equals to 8? No. Is 8 equals to 8? So we found our target. So we can update our first variable to index 2. Now let's move. Is 8 equals to 8? Yes. So uh, now we are going to update only last variable. So last equals to 3. Now move index I to 4. Is 8 equals to 8? Yes. So update the last variable to index 4. Move I to index 5. Is 8 equals to 8? Yes. So we can update our last variable to index 5. Similarly, 8 is equals to 8. So we can update our last variable to index 6. Now move I to index 7. Now 10 is not equal to update these two variables. Traversal over we have first we have two variables first with value and the last variable which has value 6. So we get the first occurrence of target at index 2, the last occurrence of target at index 6. So let us apply this logic. So when this first and last, first which is initialized with -1 and last which is also initialized with -1. Now what we were doing is we were traversing over the array. So 4 equals to 0, I lesser than nums dot size and I plus plus. If any element of array is equals to target, mm, we can update our two variables in this condition. So first, but there is a catch. We are going to update the first variable only once. So if first is equals to -1, then only update the first equals to. So I can write on it. Update first variable only once. But for the last variable, we are always updating it. So last equals to I. We are updating last each time. It last each time. So after traversal of the array, we get last position. Now in step 3, we can return our answer first and last. Let's check our code for is running fine. So it is correct, but the time complexity is we are tracing over the whole array. Taken is complexity is of n, where n is
Agam, your voice. Can you rejoin once?
the voice clear.
No, it's not.
Okay, so there is a little problem from the speaker side. Please wait for 2-3 minutes.
Hello, am I audible? Sorry guys for the interruption. Let's continue. So here the time complexities of n, where n is the number of elements in the array. But we can do this in a better time complexity. As in the given, as the given array is sorted. So as the given array is sorted, we can think of binary search. Uh, can anyone tell me how we can apply the binary search? So let's move. Let's apply binary search to find the first and the last occurrences of target in the given array. Let me first remove it. So, so the step one is same. Take two variable first and last. Initialize them with -1. Apply binary search uh, to find the first array. So simple binary search is like uh, first pointer is pointing to the zeroth index and second pointer is pointing to the last index of the array. Now we calculate mid. Mid is pointing to index 3. Now ARR of mid is equals to target. So our mid is equal to target. So index 3 can be the first occurrence of 8. So we can update our first variable to 3, but we are not sure it is the first occurrence. So we can what we can do is we can search in the left part of the array. So we can move our j pointer to mid minus 1. So now our search reduced to 5, 7, 8, index 0, 1 and 2. Now I is pointing to index 0 and j is pointing to index 2. So mid is equals to 1. Now our mid is 7 is less than equals to 8. So according to binary search logic, we will search in the right half of the array, right half of the search space. So our search space will be 8 and index is 2. Now I is pointing to index 2 and j is also pointing to index 2. Mid is also equals to index 2. Now our target is equals to mid. So what we can do is we can update our first variable to index 2. Again, we are not sure, so we can search in the left half of the search space to find other occurrences of the target in the array. So search space will be empty. So is empty, we can stop our algorithm. So now implement this step. So step 1 is again same. Step 1, declare two variables, int first initialize with -1 and last equals to -1. So step 2, find first occurrence of target. So simple binary search is equals to 0 and j is pointing to the last index. The size -1 and simple binary search logic as in j. Now we are mid index I plus j divided by 2 if mid equals to target. So as we have seen, if the mid index is equals to target, then it then mid can be the first occurrence of the target. So we can update our first variable to mid, but we were not sure about the first occurrence. So we are also traversing in the left half of the array. So for traversing in the left half, we are moving j from its current position to mid -1. Like j equals to mid -1. Else if mid is greater than target. What if like target is equals to 8 and a of mid is equals to 10. So 10. So according to binary search in a sorted array, 8 will be in the left half of the array. So we will move our j pointer to mid -1. J equals to mid -1. Else cases if mid is less than target. If a of mid is let's say 6 and target is again 8, uh, then 8 will be in the right half of the array. So we will move our I pointer to this is mid and I pointer to mid plus. So I will point here I equals to mid plus 1. after the after this loop, the first variable holds the first occurrence of the target in the nums array. Similarly, for the last occurrence of the array, we can do the same. We can apply the binary search to find the last occurrence of the target in the array. Last is initially at -1 and at index 0, and last index is pointing at j is pointing at the last index. So mid is 3. Now uh, mid is equal to target, so 3 can be our last occurrence of 8 in the nums. So we can update our last variable, but we are not sure. So we can search in the right half of the array to find the other occurrences of the target in the array. So for this, we can move our I pointer to mid plus 1. Now search space will be 8, 8, 8, and indexes are 4, 5, 6. Now I is pointing to index 4 and j is pointing to mid is this. Again, mid is equal to target. So uh, sorry. So index 5 can be the last occurrence of the target in the array. So we can update our last variable to index 5. But again, we are not sure. So we will search in the right half of the array. Now search space will be 8, 10, and indexes are 6 and 7. So I is pointing to 6 and j is pointing to 7 index. 8 equal to target. So we can update our last value 6, index 6. But as we have seen earlier, we will search in the right half of the array. So the search space will be search spaces will consist of only one element, which is 10, and which is at index 7. So I is pointing to index 7 and j is pointing to index 7. Now mid is equals to index 7. Now 10 is not equals to 8. Mm, as the array is sorted. So 8 will always be smaller than 10, and it will always be present in the left half of the array. So we will search in the left half of 10. So left half will be empty in this case. So we can stop our search now. So let's try to implement this step. Now step 3. Find of target. So again I equals to 0 and j is pointing to last index of the array. Now similarly, while I equals to j, calculate mid index. If element of the array is equal to target, then if the element is equal to target, this can be the last index. So mid can be the last occurrence of the 8. So we can last variable to mid, but we were not sure that it is the last index or not, last occurrence or not. So what we were doing is we were searching in the right half of the array. So for right half, we are moving I to mid plus 1. I equals to mid plus 1. Now the traditional binary search. If mid is greater than target, uh, like target is equals to 9 and mid is something 50. So target the left half of 15. So we will search in this left half. Minus 1. So j equals to so 9 and mid is 5. So target is greater than 5. So we will search in the right half of the array, right half of the search space. So we can move our I pointer to mid plus 1. So I equals to mid plus 1. Now after step 3, the first and the last variable holds the first and the last occurrences of target in the nums. So in step 4, we can return our answer. So answer will be first and last. Let's run code for the examples. Oh, sorry. Net. Let's try to submit it. So it is giving us correct answer.
Agam, your screen is not visible.
Oh, is it visible now?
Yeah, it is.
So it is, our code is running fine and the time complexity is log of n because to have number x by example. So n is equals to 7, x equals to 2. So basically we have to count the occurrences of x in the given line. So in this line, 2 has occurred, time answer is 4. We can do one by one like this. Let's plus if any element of array is equals to target value, then increment the occurrence of that occurrence of that number. After the travel after the whole traversal of the array, this count variable holds the occurrences of the x in the array. So we can return our answer. Return count. Let's try. So it is giving us, but it is taking off and time, and that is we are trying over the whole array. But this question help of the previous question. Can anyone tell me how we can use we, uh, target in the we can use I this code and by this example. Will point to this index. Now, if you last minus first plus 1, we can count of x in the given array. Let me show you what I'm thinking. So count equals to last minus first plus. Let's run it. I can change this value to x. I hope it will run fine now. Oh, it is giving the correct answer. So the previous logic is working fine. But there is a case when the x is not present in the given array. Then first and last will point to -1. And it is like -1 plus 1. And count value will be -1. So if first equals to -1 and last, then the element is not present in the given array, so we can return 0. Means x is appeared 0 time in the given array. So let's run it. Let's try to submit it. So our code is working fine, and the time complexity is big of log n, where n is the number of elements minutes in. So that's it for today. You can ask your queries if you have any.
Okay, so thank